For this video, I'm going to walk you through uncertainty in measurements and sig figs that we use a lot in chemistry. So obviously measurements are going to be very important in chemistry. We are a numbers science. We make a lot of measurements in lab, and then we use those measurements in problems. So we have to be very good with measurements here. Obviously measurements have a number and a unit. That's a big thing that people mess up. You cannot forget the units here when you're doing these problems and you have numbers with units. They're very important for our experiments, so you need to make sure these measurements are correct. We absolutely must have good measurements here for our labs, otherwise all our data is going to be flawed. So we need to take good measurements. When you make a measurement in chemistry, it's important that you write down all of the digits that you are sure of that the instrument gives, and then you always have one uncertain digit that's going to be estimated. So if you're recording a measurement correctly in chemistry, you're writing down all the digits you're certain of and one digit that's being estimated. All right. And then people will say, well, why would I have this estimated or uncertain digit? Well, there's a couple of reasons here. First, these instruments you're using are never free of flaws. Your balance may not be calibrated correctly. Your ruler may not be precisely set up to the exact measurement. So there's always some form of flaw here in your measuring instrument. And if you're doing measurement correctly, there has to be some type of estimation involved. So it's very important in chemistry. You're writing down all the digits you're sure of, and then one that you're unsure of or that you're estimating. And I'll show you what that looks like in a few examples here. A couple of things to point out first. If you're using a balance with a digital display, the final digit on that display is always the estimated digit. Okay, so if you look here at this example, looks like we put some gold on the balance and we have 45.22 grams of gold. If you actually watch the balance when you put that on there, you'll see the balance will pretty quickly settle on the 45 and then maybe the point 0.2. And then that last number will kind of fluctuate a little bit. It might go up, might go down. And it's finally like the balance just gives up and settles on the 0.22. Okay, so that last two is the estimated digit. Maybe it's really closer to 1. Maybe it's really closer to 0.23. Okay, but the key is the balance is estimating that last digit. Right? If you're doing a scale, first thing here, if you're doing something like a graduated cylinder, it's very important that you are measuring at the bottom of the curve. We call that the meniscus, and you still are estimating the last digit. And in order to do this correctly, you would need to read this at eye level. So if you were reading a graduated cylinder in lab, you'd have to have it setting on the lab table. You'd have to get down at eye level, and then you have to read it at the bottom of the curve. So if you look at the example here, you can see this here on the right. You can see that the liquid here in this graduated cylinder curves down. If you were to read it kind of off to the side here, you might think that there's actually probably over 45 milliliters of water in there. But you can see when you're reading it at the bottom of the curve that the level doesn't even actually hit the 45 mark. Okay, so that's very important. And the key here is what we were talking about with this estimating a digit here. If you look closely at this, what would you say is the amount of water in there? All right, take a look and see if you can actually figure it out. I would say if I was reading this, I might say there's about 44.9 milliliters. Okay, it hasn't quite reached 45, but I know it's greater than 44. So I estimated one digit based on the scale. Notice, I could not say, oh, I think there's 44.95 milliliters, because then I'd be estimating two digits. Okay, I'd be estimating the 9 and the 5. Remember, in order to give a measurement correctly here in chemistry, you're giving all the digits you're sure of and one you are estimating. So I'm absolutely sure that this amount of water is 44 point something, but I estimated this last number. Maybe you think it's 44.8, okay? The key is that last digit is the uncertain digit, and that's how you record these measurements correctly in chemistry. All the digits you're sure of and one you're estimating, and it changes based on the scale as you're going to see. So with these scales, you do have to read at the meniscus, okay, at eye level. This example can be really helpful here to help people understand this uncertainty idea. So if I took a block of wood and gave you a ruler here and told you to figure out the length of the block of wood, okay, look at how this can change. So if I gave you a ruler here and I just told you that the ruler is 1 meter long, and I said, okay, what is the length of this block of wood? Well, you can see how it's recorded here. It's recorded as zero point 0.6 meters, 0.6 meters. I am absolutely sure that it's not 1 meter, so 0 point. But then I estimate that one digit, okay, zero point 0.6. Notice I didn't say 0.60 because then I estimated two digits, okay? If you're doing this correctly, there's one digit you're sure of. I'm absolutely sure that it's 0 point something, and then one digit that I'm estimating, the 6 in this case. But notice the second example here. What if I give you some more markings now on that ruler? Okay, now you can be absolutely sure that it's 0 0.6 something. Okay, based on the scale here, I can see it's at least zero point 0.6, and then I estimate one digit. I think it's 0.61. Maybe you think it's 0.62. All right, the key is that last digit is the estimated digit. All the digits I'm sure of, and then one I'm estimating. And again, what if you add some more markings here to the ruler? Now I can be absolutely sure it's 0 0.60, and I estimate one digit, okay? I think it's 0.607. Maybe you think it's 0.606. The key is that last digit is the estimated digit. And that's how you record this correctly in chemistry. All the digits you're sure of and one that you're estimating based on your scale. We can look at this with volume as well. So for example, here, if you look at these three different ones, you can see here on the left, I have this listed as 5.72 milliliters. Based on the scale that they gave me, I'm absolutely sure it's at least 5, not 6. I'm absolutely sure that it's at least zero point 0.7. If you count up the lines, it's at least zero point 0.7. But then after that, I have to estimate my one digit. I think it's 0.72. Maybe you thought it was 0.73. The key is I read it at the bottom of the meniscus, and I have all the digits I'm sure of and one that I'm estimating. And based on the scale they give you, the number of digits you can record changes. So you have to always pay attention to your scale and make sure you're giving all the digits you're sure of, and then you're estimating only one digit when you're recording this. Now this brings us to significant figures, which we also just call sig figs in chemistry for short. Sig figs get a bad rap. People really get annoyed or confused with sig figs, but really all sig figs are is just counting. If you can count, you can do sig figs. The key is you need to know the rules, all right? But literally, it's just counting digits, all right? So sig figs by definition are all the numbers you're sure of and then one that you're uncertain of or one that you're estimating, basically like we've been talking about. So in chemistry, when we do math problems here, we have to follow proper sig figs. All right. So before we get into worrying about doing math with sig figs, you need to know the rules here for sig figs. And there are 5 rules that you need to follow. All right. The first rule is the easiest. It says all non-zero digits are significant. What that means is if you have a number that's not a zero, a digit in your number that's not a zero, it counts or it's significant. Okay, so let's just do an example. Let's just say I had the number here, 316. All right, if I asked you how many digits are in that number, just digits, not sig figs, just how many digits, you would say there are 3 digits, right? There's a 3, a 1, and a 6. So this would have 3 digits here, okay? But now the key is, what if I said how many sig figs are in this number? Okay, well, according to the first rule, any digit that's not a zero would be significant. So all 3 of these numbers are not zeros. So this number, 316, would have 3 sig figs. Okay, so if you're looking at a number, you look at each digit individually, and if it's not a zero, it counts towards sig figs. All right, so even if we did another one here, what if I had the number 1,678. Okay, well, that has four digits. None of them are zeros, so that number would have four sig figs. Okay, so like I said, the first rule is the easiest, and literally sig figs are just counting. Okay, if you can count, you can do sig figs. The rest of the rules here for sig figs deal with zeros. When do you count zeros and when do you not? Okay, so the second rule says zeros between other sig figs count. So if you have zeros smushed in between digits that count, then you would count those zeros towards sig figs. All right, so for example here, the number 1002. Right? We already talked about how any number that's not a zero is significant. So this one counts, this two counts. So since these zeros are smushed in between sig figs, they would count as well. So you just count up the digits now in this number. This number would have four sig figs. All right. So any zeros that are smushed in between sig figs would count. So even if you had the number here like 41,005. All right. The 4 and the 1 both count. The 5 counts. And these zeros are smushed in between. So this would have a total of 6 sig figs in that number. Okay. So it's just counting. The third rule for sig figs talks about zeros at the end of a number here before the implied decimal point. All right. If the zeros are at the end of a number and not smushed in between sig figs, they don't count. However, there's this little trick we can do in chemistry. If you sneak the decimal point in, that makes those zeros count. You're not used to seeing numbers written like that, but in chemistry, it's a way to kind of make digits count if you need them to count. Okay, so if you look at this number here on the left, 12,400. All right, the 1, the 2, and the 4 count right away because they're not zeros. All right, these two zeros here at the end on the right, though, don't count. They're not smushed in between. There's no decimal point. So this number would just have 3 sig figs. All right, but the other number here, the 400 decimal point, and yes, that is not a misprint. You got to get used to that. 400 decimal point would also have 3 sig figs. Okay, by putting that decimal point in, the 4 always counts, and with the decimal point there, this 0 and this 0 count. So there's 3 sig figs. Okay, so you just got to get used to seeing that. If you see the decimal point there, those zeros at the end count. If there's no decimal point, those zeros at the end of the number don't count. The fourth rule here is talking about when a number is smaller than 1. So essentially a 0-point number. All right. Any of those zeros before your first sig fig don't count. Okay. So if a number is smaller than 1 and you have a string of zeros, any of those zeros before you reach your first sig fig do not count. So in this example here, we have 0.045. Obviously, this is less than 1, right? This first 0 doesn't count because left to right, you haven't reached a sig fig. It's very important here that when you're looking at these numbers, you're doing a left to right kind of analysis. So as I move then to the right, another 0, haven't reached my first sig fig yet, doesn't count. But then once I hit the 4, okay, that counts, all right? And then obviously the 5 would count as well. This would have 2 sig figs. So if your number is less than 1, okay, a 0-point number, your string of zeros until you reach your first sig fig left to right don't count, all right? So even if I had 0.000003, okay, all of these zeros would not count. But once I hit my first sig fig, boom, that would count. That would just have 1 sig fig. And the last rule here is talking about zeros after the decimal point counting as long as you have a sig fig moving left to right. Again, we're analyzing the number moving left to right. So any 0 after a decimal point will automatically count if moving left to right, you have a sig fig. So if you look at this example, 45.8300, right? As soon as you see the 4, that counts because it's not a 0. Any 0 after the decimal point is automatically going to count. All right. So this number, this example here, would have 6 sig figs. All of the numbers here, all of the digits would count towards sig figs because these zeros are after the decimal point, but left to right, you've already hit a sig fig. So once you hit your sig fig, left to right, those zeros after the decimal point automatically count. So let's try some other examples here. Let's just say I had 0.0048. If I asked you how many sig figs does that number have, okay, that would only have 2 sig figs, all right? The zeros don't count until you reach your first sig fig, all right? The 4 is the first sig fig, and then the 4 and the 8 count. So that would just have 2 sig figs, all right? What if I did this? How many sig figs would that number have now? All right. Again, left to right, those zeros don't count until you hit your first sig fig. So the 0.00 do not count. Once you hit this 4, okay, that's your first sig fig. That means all the other zeros to the right of that would automatically count. So you don't even have to think about it. Once you hit your first sig fig left to right, all the zeros after that point would count. So this number would have 4 sig figs. All right. Notice, what if I did this? 20.004800. By putting that 2 in front, this 2 counts. So all the zeros after the decimal point automatically count. This 0 is smushed in between all numbers that count. The decimal point is there. So every single one of these would count. So if I asked you for sig figs in this number, it would be all 8. All right. So sig figs definitely take some practice. You have to follow the rules, know the rules, and go through and do a bunch of examples until you get the hang of it. But it is something that you do need to follow in math problems in chemistry for the entire course. So you got to be good with sig figs. So now we're going to look at rounding with sig figs. I told you we do a lot of math here with sig figs. We're just not quite there yet. So you do have to usually round with sig figs here. And typically these follow math class rules, but there is some slight exceptions here. So the first thing you need to know is that if you have a digit to the right of your sig figs being less than 5 and you need to round it, you would just leave the number where it was at. All right. So this is easier to see with examples. For example, if you had the number 56.43 and you know that you needed 3 sig figs. Again, I'll show you how you know how many sig figs you need in a second. But for right now, let's just say you needed 3 sig figs. So you immediately know here with this, okay, the 5, the 6, and the 4 left to right are your 3 sig figs. So you look to the number to the right. It's a 3. All right. Because that's less than 5, you just leave your 56.4 where it's at, and your answer would just be 56.4. Okay. So let's look at another one here. If the digit to the right is greater than 5, you would go up. So let's just say you did your math, your calculator spits out 67.39, and you can only have 3 sig figs. So left to right, the 6, the 7, the 3. Those are your 3 sig figs. You look to the right of that now. There's a 9. 9 says you got to go up. So your answer here would be 67.4 with correct sig figs and rounding. All right, so that's pretty similar to math class. The weird one here in chemistry is, what if the digit to the right equals 5? The rule in chemistry is you go for even numbers. All right, the digit to the right equals 5, you go for even. So again, you need to see this with examples. If you had the number 94.65 and you needed 3 sig figs, so you have the 9, the 4, the 6. Those are your 3. You look to the right, it's a 5. 5 says go for even. Well, the 6 is an even number, so your answer would stay at 94.6. But if you had the number 94.75 with 3 sig figs, the 9, the 4, and the 7 are your 3 sig figs. You look to the right, you see a 5. 5 says you go for even. Well, the 7 is not even, so then you would have to round it up to 94.8. The key is, if it's not an even number, you would go up. You never go down to an even number, you go up. And we always consider a 0 to be an even number. So this is just something you need to practice, okay? You got to be good with sig figs here, but you got to pay attention to these rounding rules. The hardest one is the 5. If it equals 5, you got to go for an even number. So we learned how to count sig figs. We learned how to round with sig figs. the whole idea of sig figs here is that we're going to be using them when we do math problems in chemistry. And there's separate rules you need to follow for multiplication and division, and then addition and subtraction. So you have to know these rules and you have to pay attention to what you're doing. So if you're doing a multiplication or division, all right, you would count sig figs in each of the separate terms that you were multiplying or dividing, and then you would use the least amount of sig figs in your answer, all right? So if you're multiplying or dividing, you count sig figs in each of the terms, and you use the least number that you had in your answer. All right. Remember, this is a measure of your level of uncertainty here. You can't be more certain than your, uncertain measurement. So let's look at an example. This is easier to see through examples. So let's just say you had to multiply these numbers in your calculator, 3.052 times 2.10 times 0.75. Your calculator would spit out this number. If you wrote that down as your answer, you would see me right nearby -1 SF. Basically, you lost the point for sig figs. So if you're multiplying or dividing here with sig figs, you count the sig figs in each of your terms and use the least. So this is why you need to know how to count sig figs. So I look here at this first term, right? How many sig figs are in that number? Okay. Hopefully you figured out that there were 4 sig figs. So all of them count. That 0 is after the decimal point, but left to right, you've already hit a sig fig when you hit the 3, so all the zeros after the decimal point count. Same thing for the 2.10. This would have 3 sig figs. All right, the 0 after the decimal counts because left to right, you've already reached a sig fig. But this one will only have 2 sig figs. That first 0 does not count because left to right, you haven't reached a sig fig until you get to the 7. So I had 4 sig figs, 3 sig figs, 2 sig figs. The least amount I had was 2. So that means my answer needs to be rounded correctly, okay, to 2 sig figs. Even if you have 2 sig figs but you didn't round it correctly, you would lose a point for sig figs because your rounding with sig figs was wrong. All right, so my answer can only have 2 sig figs. So I say, okay, the 4 and the 8 would be my 2. I look to the right, it's a 0, so I stay. My answer with correct sig figs would be 4.8. Anything else that you would write down would be -1 for sig figs. So if you're multiplying or dividing, you count sig figs in each term and you use the least number in your answer. But this is different for addition and subtraction. For addition and subtraction, you don't count sig figs at all, okay? You don't even need to know how to do sig figs for addition and subtraction. You just need to know to follow the rule. The rule for addition and subtracting is you count decimal places in each term and you use the least amount of decimal places in your answer. You're not counting sig figs here. You're only counting decimal places in each of the terms. So let's just say, for example, you had to put these numbers in your calculator, 3.45645 milliliters minus 2.43 milliliters. Your calculator spits out that big number. If you wrote that answer, you would get -1 SF. The rule for adding or subtracting is you count decimal places in each term. So if we just look at the decimal places in this first term, okay, how many numbers are after the decimal place essentially? This would have 5 decimal places, okay? This number here would just have 2 decimal places. So we counted decimal places in each. The least amount is 2. So that means my answer can only have 2 decimal places, not 2 sig figs, 2 decimal places. So that means I have to go 2 spaces, okay, past the decimal point, so 1.02. You look to the right, it's a 6. 6 says you got to go up. So the correct answer here would be 1.03, and because this had units, milliliters. That's the only answer that would get you complete credit here. Right? It's rounded correctly and it has the right number of sig figs. In this case, though, we used decimal places. So you have to be good with this and you have to know these rules. If you're multiplying or dividing, you count sig figs and use the least number in your answer. If you're adding and subtracting, you count decimal places and use the least number of decimal places in your answer. Here's your chance to try some examples. So the first 2 just want you to count sig figs, and then the last 2 are actually going to have you use your math with sig fig rules. So I would say pause the video right now, try these, and when you come back, you'll see the answers and see how you did. So pause the video. right now. So hopefully these are the answers that you got. For the first one, these zeros at the end don't count because there's no decimal place there. So it's just the 9, the 1, and the 6 count. So it's 3 sig figs. Uh, for the second one, this string of zeros in the beginning do not count because left to right, you haven't reached a sig fig. Once you get to the 3, though, that's your first sig fig. So every number after that to the right would count. So that means the 3, the 0, and the 5 all counts. There's 4 sig figs. When you look at the third one here, you are adding. So the rule is you count decimal places in each term and use the least. The first term has 5 decimal places. The second one here has more than 5. So your answer has to be rounded correctly to 5 decimal places. Right? Not sig figs, 5 decimal places. So that's the answer you get when you do that correctly. For the final one, you're multiplying, so you count sig figs in each and use the least. This one would have 4 sig figs, they all count. This one would have 5 sig figs, and this one would have 3 sig figs. So the least amount is 3. So when you give your answer here, you need 3 sig figs. So notice this one has 450 with the decimal point. That's how you can make that number have 3 sig figs. All right, so a couple things I just want to point out here. If you ever see a number with scientific notation, so for example, if you saw 1.25 times 10 to the fifth and you were asked how many sig figs, basically to do that, you ignore the scientific notation part completely. You don't have to expand the number out, nothing like that. Basically, you ignore this part completely and you only look at the number that's before the multiplication symbol. So this 1.25 times 10 to the fifth would have just 3 sig figs. You don't have to write it out. You ignore the times 10 part completely and just look at the number that's there and count the sig figs. Okay? And something else to take note of, sometimes the only way you can get proper sig figs is to put a number into scientific notation. All right? Let's just say you had the number 1300 and you needed 3 sig figs. All right? You had to have 3 sig figs. Some people say, oh, well, I'll just put a decimal here. Well, you can't do that because you now have 4 sig figs. Some people say, well, oh, I'll just make it a different number. I'll just make it 130 decimal place. There's my 3 sig figs. Well, the problem is you just made 1300 become 130. So that does not work. All right. Sometimes there is some crazy rounding and you do a lot of rounding with these sig figs, and that's just the way it is. But you can't drop off an entire place value here. So the only way you could get 1300 to have 3 sig figs would be to put it into scientific notation. So you'd have 1.30 times 10 here, 1, 2, 3, times 10 to the third, and that would be the exact same thing as 1300. The key is this here would have 3 sig figs the way it's written, okay? So sometimes you have to use scientific notation. That's the only way you can get the proper number of sig figs. So that's just something to watch out for. But definitely know your sig fig rules, including the math rules here.